Okay, guys, we're going to look at equivalent fractions. Well, equivalent fractions is actually really easy. You already know how to do these. It's just a matter of thinking about it and putting it in place, okay? So equivalent means the same, fractions are the fractions. So if you look here, I've given you 4 examples of equivalent fractions, and I'm using half because half is pretty simple to see, okay? I know that 1/2 is 0.5. Right? I know that 5 out of 10 is 0.5. Ooh, that was a horrible 5. Okay, I know that 10 out of 20, if I reduce that, is the same as 1/2, which is 0.5. I know that 5 out of 50 out of 100, excuse me, I can reduce that. 5 out of 10, look at that, 0.5. They are exactly the same. Thus, these are equivalent fractions. Okay, literally equivalent fractions means just that. They're the same. When you reduce them down to the bare bones fraction, it's exactly the same. All right, so let's look at some examples and let's get some vocabulary done. So math terms, proper fraction. A proper fraction is a number that is a number where the numerator is less than the denominator. Guys, this is your normal fraction. 1/2. This number on top is less than the number on bottom. 3/5, 8 out of 10, whatever. You're talking about your normal fractions. Now, these are not equal to each other. However, they are all proper fractions. Okay, an improper fraction is flipped. So it would be 2/1 or 5/3 or 10/8. Those are improper fractions, okay? We're looking at proper fractions, all right? The property of 1. The property of 1s means anytime you multiply anything by 1, it's itself. So its example is 6 times 1. So 2 times 2 is 4, right? But 2 times 1 is 2. So anything times 1 is itself. Okay, so I could say 5 times 1. I could say 12 times 1. It doesn't matter. It's still itself. Okay, so let's look at a couple examples. All right, first thing I want to do, I want to do an experiment. I want to shade each figure separately. Okay, so I've got 3/4 on this first one. So there's 1, 2, 3. Okay. The second one, so that one's good. Second one is 6 out of 8. So there's 1, 2, 3, 4, 5, and 6. And then this one is 9 out of 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 out of 4, 6 out of 8, 9 out of 12. Well, what do you notice when you look at these? Well, first thing I notice is the 6 out of 8, all they did was take and draw a line in the middle of the 3/4. That's the same thing. Well, and then the 9/12, what they did here is they took the 3/4 and they just divided it into thirds instead of in half. Then I notice here's 1 row, 2 rows, or columns, excuse me, 3 columns. So that's 3 out of 4 columns. Well, look at that. There's 1, 2, 3. And because it goes on both sides, that's the same as 3/4. Then let's look at this one. There's 1 column, 2, and 3. And I have 1 column over here left over, 1 column over here left over, 1 column over here left over. So this is the same as 3/4, which is the same as 3/6, or excuse me, 6/8. So these are all equivalent. So these are equivalent fractions. Again, when you reduce them, they come back to being equal to each other. Okay? okay? All right, so let's see if we can complete these fractions. So this one right here is 1/2. I've got one part, two parts. Okay, so 1/2. But look at the second one. There's 1, 2, 3, 4. So 2 shaded, 4 total. Remember, my shaded and my total is always the bottom. Okay, and then the shaded is the top. And remember, when we did this, it was part over whole. That's how you make a fraction, part over whole. Okay, so 1, 2, 3, 4, 5, 6. So the bottom here is a 6. I can keep doing this. 1, 2, 3, 4, 5, 6, 7, 8. So my bottom number is an 8. But let's look at how much is shaded. So I've got 1, 2, 3, and 4. Okay, let's do it again. Total number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And now just the part that's shaded. 1, 2, 3, 4, and 5. And I can tell by looking at the green marks, these are exactly the same. Here is half. Here is half. Here is half. Here's another half. And yet another half. So these are all half. Okay? They reduce down to half. Okay, so let's do this one. 1, 2, 3, and 4. And how many are shaded? 1. Okay, so this is 1/4. All right, well, let's do this other pink one. 1, 2, 3, 4, 5, 6, 7, and 8 is the total. Well, for these to be equal, how many does need to be shaded? 1 and 2. Okay, so again, these are equal to each other. All right, last one. 1, 2, 3, 4, 5 is the bottom number, my numerator. Excuse me, my denominator, haha. And my numerator would be 1. All right, let's do this one too. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 is my denominator. And my numerator, 1, 2. Okay, again, these are all equivalent fractions. So what you're going to do is you're going to see if you can figure out, well, how do I get that second number? If I only have this part, how did I turn it into that? Okay, so that's what we're going to do right now. All right, so let's take a look. I have 3/4, 3/8, 9/12, 12/16. These are all equivalent fractions. Well, if you look what I did right here, I took 3/4 and I multiplied it by something to turn it into 6/8. Well, what did I do to the 4 to turn it into the 8? Well, 8 divided by 4 is 2, so in order to turn the 4 into the 8, I had to have multiplied by 2. And I know from math what I do to the one side, I must do to the other. Okay, so this one had to have been multiplied by 2 as well. This is where the 2/2 comes into play. 4 times 2 is 8, 3 times 2 is 6. Okay, why do you think multiplying a fraction like 2/2 or 5/5 is the same as property of 1? Well, it's real easy. This is multiplying by 1. Okay, so if I were to take and draw this and make this look like a 1, it's a horrible 1. However, there's my 1. Well, this is what I'm seeing. I am increasing the size of the numerator and the denominator by the same amount. Okay, I am enlarging both numbers at the same time. Thus, they are equivalent fractions. I'm not skewing 1, which means multiplying 1 by a different number. Okay, I've got to make sure I'm multiplying it by the same number. So let's do a couple examples. Okay, I want to turn 2/5 into something over 15. Well, how do I find out what this something is? Let's look. Okay, so I am going to take and I'm going to turn 5 into 15. Well, 15 divided by 5, oh, that's 3, because 3 times 5 is 15. So that means that I had to have multiplied here by 3. And I know whatever I do to one side, I must also do to the other. So I'm going to multiply the top by 3. And I know 2 times 3 is 6. So my missing number here is 6. Okay? Let's do a couple more. All right, 1 turns into 8. Excuse me, 2 turns into 8 and 1 turns into something else. Well, I know 8 divided by 2. 8 divided by 2 is 4. So that means this one had to have been multiplied by 4. By 4. Sorry about that. And whatever I do to the top and the bottom, I must do to the other side, right? So 1 times 4, this would give me 4. Okay, same thing here. But look, now I don't know the bottom number. Does that matter? No, not at all. So 3 and 12, well, 12 divided by 3 is 4. Okay, so I know 4 is what I multiplied by. I'm going to multiply this by 4, so 3 times 4 is 12. What I do to the top, I must do to the bottom, which means this has to be multiplied by 4 as well. And 5 times 4 is 20. Okay, that's easy peasy. All right, let's look at another one. One more. Uh-oh, look at that. Now my number's not getting bigger, my number's getting smaller. What do? You know something? You do exactly what you did before. You're going to figure out, what did I do to 20 to turn it into 5? Well, I can go backwards, right? I divided before, now I can multiply. It's easy, okay? So I know 20 and 5 have a relationship, okay? Again, if I can't remember my multiplication tables, I know that 5s are just like a clock, okay? And I know the 20 marker on a clock is where 4 lays, okay? Well, what happened? 4, 20, and 5, what's the relationship? Well, 20 had to be divided by 4 to turn it into 5. What I do to the bottom, I must do to the top. So I'm going to divide the top by 4 as well. And 8 divided by 4 is 2, which means our final answer is 2 out of 5. Okay? All right. Take a moment and do some of these on your own, and let me know if you have any questions. Have a great day.